We're going to be doing now a problem so that to doing multi-step synthesis. So I'm going to be copying this. Okay. What is the molecule that I have here and the steps that we need to be following to do that synthesis? So my molecule is this alkene. And it's said to predict the products after we do the following reactions. First, say you treat it with hydrobromic acid. Second step, you do sodium amide. Third step, you do hydroboration, oxidation, and the fourth reaction that we're going to be doing, it is like into stages. Let's throw it separate. We're going to be doing again sodium amide. This is an NH2. Sodium amide, and then we're going to be doing ethyl bromide. Now, so it looks complex, but we're going to do step by step. And we're going to be able to do that. So the first reaction, it is a hydrohalogenation of an alkene. That happens in Markovnikov fashion. So we're going to have the H at the least substituted and the bromine at the more substituted. So let's throw here, reaction after reaction 1. What is that I get? So again, we said H here, bromine here. So your product is going to be this. So that is a product of reaction 1. Now, looking at the other reagent, the second reagent here is a very strong base. This is sodium amide. Sodium is my counter ion. It's a small base and very strong. Remember that we can have here, this is your alpha carbon. The second reaction is a beta elimination. So here you need to identify the beta position. If this is alpha, this is beta, beta, and beta positions. Now, small bases favor the decisive product. So if you have that elimination, meaning that you need to form the more substituted alkene. If you do the elimination over here, you're going to get that decisive product. And so this is what you form. So again, you're doing the elimination, say, well, one of the hydrogens over here, you're going to make that alkane. Yes, so we're removing, say, the leaving group and one hydrogen here, you're making that. This is the metal and the other metal. That is a decisive product. We did that because that's a small base. Okay, so that's the product after that reaction. Then it says predict the product. Let's see what happens in reaction 3. Reaction 3, it is a hydration, that is hydroboration oxidation. That is a hydration of an alkene. And that we know happens, that hydration. With that reagent, we're going to be doing anti-Markovnikov. Anti-Markovnikov, and also same fashion. So what is that we're doing? If it is anti-Markovnikov, you're going to have the H at the more substituted in the OH at the least substituted. So we're going to get the following alcohol. Again, OH at the least substituted, H at the more substituted, anti-Markovnikov fashion. So that is the alcohol that we're forming. Now, this is the result of step 3. Step 4, what are we doing here? Again, that's a strong base, and that actually is an acidic hydrogen. So this is simply a proton transfer reaction, so acid-base. Base here is your sodium amide. You're gonna get, let's do this explicitly so you guys remember what are we doing. The base is gonna get that proton. And you're gonna form, after the proton transfer, you're gonna make the following anion, and of course you're gonna form ammonia. So the conjugate acid of the amide, so you're removing this hydrogen, yeah? And what is happening, so that's the step 4. What is happening in the step 5? In the step 5, we're adding ethyl bromide, 1, 2 carbons, yep. And maybe, by the way, you may see this region in a different way. You may see ethyl bromide, of course, written this way. Same thing, but it shows it shows better for the mechanism. So now what we have here is a strong base, a strong nucleophile. And here we have a primary alkyl halide. So what happens in step 5 is an SN2 reaction. So what we're doing then is we're going to be doing a nucleophilic attack over to this carbon, and this is going to go. So my final product, I'm going to have to draw it small if I don't want to remove all that. Or maybe I shift this over, throw it higher. So I started with this, that alkene, that it was my initial molecule. So after step 5, you're going to attach an ethyl group here. So your final molecule will be that, so an ethyl group here. So notice what we did was throw the products after each of the steps. Step 1, hydrohalogenation, Markovnikov, so H here, bromine here. That's what we did. Second step is a beta elimination. So it is an E2. Also call that again, beta elimination. We need to identify this is alpha, beta position. So small bases will give you the decisive product. So the more substituted alkene. The least substituted, the Hoffman, is using either this two. So, but for that, you will need a bulky base. So if you wanted to, if you did potassium terbutaoxide, you will have this alkene. This is not what we're making. That's here, this is a Hoffman alkene. This is decisive. We're making that because this is a small base. That's after step 2, the E2 elimination. In step 3, we're using hydroboration, oxidation, that is a hydration, anti-Markovnikov, meaning that you will add then the H of the more substituted, the OH of the least. Step 4 was an acid-base reaction, strong base, removing the acidic hydrogen of the alcohol. And here you're making a good nucleophile for the last step. You're making an SN2 reaction. So finally, you're incorporating an ethyl group in the molecule. So that's how you would then predict products if you have multi-steps to draw step by step.